Okay, so the purpose of this video is just to really go through some of the areas around using OSC with Sonic Pi and Unity. We did cover this in the lesson just before the end of term 2, but unfortunately the video recording for some reason didn't work, which meant that a lot of you were trying to find out how to do this and didn't have any means of discovering it, so apologies for that. Obviously this will hopefully give you enough information to work from for your particular pieces of work, but also remember that I will be arranging for an OSC drop-in day session for anyone or any group who is looking to get a little bit more deep into this or to solve any problems that you may have. So what you can see on the screen at the moment is the Sonic Pi interface and the Unity interface, and I've downloaded a OSC. It's basically a full solution for OSC communications. I will put the link to this along with the video so that you can download that. It's free, it's open source, so you can use it to your heart's content. There is one issue with it, which that it is not quite as straightforward as some of the paid OSC toolkits that you can get for Unity, but it should do everything you need it to do. So first step really is to grab hold of that OSC library, download it and import it into your Unity project. Now when you've done that, what you'll find is that there's a number of scripts that comes along with that. So first of all, you'll notice that we have an OSC helper. We will come back to that in a bit, but we also have an OSC folder, and that folder contains all of the main pieces of code that do the OSC engine, for want of a better phrase. Without going too much into detail, OSC has a number of different means of communication, and you have to remember that those communication means can be input and output. So for example, we are just using a message sender in this example, so we're sending information from Unity over to Sonic Pi. But in theory, you could also do that the other way round, so send messages from Sonic Pi into Unity, or alternatively send messages and receive messages in both directions between a number of different pieces of hardware and software. So this is really kind of the basic starting point, and then you can obviously go a lot more in depth into that. But all of these scripts that you can see here in the OSC folder are what allow Unity to do those OSC communications both as a server and also as a client, but we'll come back to that in a bit more detail in a second. The other thing you'll notice with this particular library is that it comes with a menu item, a helper menu item, which is put into the editor folder, which is in your assets in Unity. Now the reason why this is important is because that has to be in the editor folder for it to work, and the editor folder has to be in the root of the assets folder, again for Unity to find it. So if you move that or rename the folder or anything like that, it will stop working. Now that's not a massive problem because it doesn't actually do a huge amount. It just allows you to see whether Unity is successfully sending or receiving commands on OSC, pretty much like the oscillator package that we saw in the lesson. So basically just be mindful of the fact that it's there, but you don't have to do anything with it. It will just work how you expect it to, as long as you don't change the name or move the folder. So if you need to get to the OSC helper, you go to Window OSC Helper and you'll see this little dialog box, and you'll notice that it says that at the moment you can't see anything because we're not running the example. There is one final step, which is this OSC script that you get that you have to customize. This particular one, the OSC controller handler, is quite long in terms of the script, but it doesn't have a huge amount that you need to change. Really what you're looking for are the setup functions, so the initialization or init function, and what you'll notice there is that I've added a line, or I've modified the existing line should I say, where it says create client. So what this is going to do is to create a transmitter, as you can see from the comments, and we need to give that some information in order for it to work. First of all, we need to obviously call create client, which is the method that is used for creating the client itself. We need to give it a name, and in this case I called it Osculator because when I was using Osculator, the program, it just made it easier to see those messages come through on that. You can call it anything, it's not massively important, but obviously if you name it something that you understand, it does help when you're looking at debugging and sending information and so on and so forth. For the next part of this command, we have to give an IP address. Now, as you know, OSC can be run across a network. So if we were, say, using one machine to send a message to another machine on the network, we may choose a different IP address there. But for our purposes, we're using the same computer that we are developing on. So we need to use the special local host IP address that we've discussed before, 127.0.0.1. And finally, we have the port number. Now, the port number in the latest version of Sonic Pi for OSC messages has changed. It used to be 4557. It is now 4559. Now, if you're using Sonic Pi version 2.11.1 or above, then that's fine. If you're not using Sonic Pi version 2.11.1 or above, please download, install, and start using Sonic Pi version 2.11.1 because it comes with a newer way of using OSC that's a lot more stable than any previous methods, and it's finally kind of supported, so you need to make sure you're using that. But that's why we've got those numbers and commands in there. And what this is doing, the create client command is setting up a client transmitter that is going to send messages to the local host, so back to ourselves, but via the port 4559, which is the port that Sonic Pi uses to pick up OSC commands. And that's all we need to do with that script. We can save that, close it, done. We don't need to do anything else unless we're creating another transmitter or a server if we're sending messages back to Unity. Now, what you would then need to do is add in some code that triggers the OSC commands, because obviously if you just leave it as is, nothing will happen because there are no commands being sent. So in my player controller, which is attached to my rollerball object, I have a command where I'm bringing in the library, so line 5 using Unity OSC. I've then got a line where I have to set up the client and server information. This is this dictionary line. It looks confusing, don't worry about it. It's just there because the OSC library that we are using has a very sophisticated set of logging data, so you can kind of track what has been happening through event messages and all that type of stuff. This is just there to ensure that all of the commands know what the server is to send all of these different commands through. And you can obviously have more than one server, but for our purposes, we don't need to worry too much. We just need to have that line there. And then finally, in the start method, I've got a OSC handler command. So I'm calling the OSC handler script that we were looking at before. I'm asking it to initialize, which is obviously where we were using our commands to set up which port and which IP address to use. And then I straight away send a message. And the reason why I do this is just to test that it's working. Now, the message itself is quite interesting because there are a number of things that we can use in messages in OSC. Essentially, for our purposes, a basic one is where we say we want to send a message to the client, so we know where we're going to send it to. We then have to say what the message is. So first of all, we have to say what the client is that we're using. So that's the oscillator that we put in before. We then have to tell OSC what the command path is, which is where it says Sonic Pi Unity trigger. And then we give the command itself, which in this case is loopy. Now, the reason why OSC is so useful is because you can send a huge amount of different types of data across these communication channels. What that means is that where I've got loopy as a string at the end of this command, that's just a string. So it's a string message that's being sent to Sonic Pi, and we'll see how Sonic Pi deals with that in a second. That is not the only type of thing that you can send. For example, I could send position data of an object in number form, so integers or floating point numbers or whatever it might be. And I could send those again over to Sonic Pi and have Sonic Pi do stuff based on those. It's just in this case it's a lot easier to try and track messages, so text-based messages, rather than trying to do a huge amount of work with kind of individual numbers, whether they be floating point or integer or whatever. But just to let you know that basically that is one way of doing it. It's not the only way to do it. That's what I was trying to get to. You'll also notice that you've got this kind of path where I've put Sonic Pi Unity trigger. That again can be anything. It doesn't have to be that long. It can have more than that. It can have less than that in terms of the amount of arguments that goes into that. Really, the reason why it's there is so that you have a means of tracking where the messages are coming from and what they're meant to do. So I usually use quite descriptive ones in this because then I can track what's going on. But anyway, that will ask Sonic Pi to do something when Sonic Pi starts. When Unity starts this particular player controller class. You'll also notice that I've also got an event trigger, an on-trigger enter event down the bottom, and you'll notice here that I've got another OSC handler that I'm sending a different message to. In this case, I'm using the pickup message instead of the loopy message as earlier. And if you look over onto the Sonic Pi window, what you'll notice is that those message names are replicated over there. Now, in this case, the Sonic Pi commands are slightly different to what you may have seen before. They're slightly more traditional programming rather than, playing notes and that type of stuff. But the reason why I've done it this way is just to give you a rough idea of how you can use these bits of information. Specifically, what we're seeing here is that Sonic Pi is going to start up and play one note, which you can see in line 4. It's then going to get a value from this sync command, and that sync command is what the OSC libraries within Sonic Pi use to communicate across obviously all of the different bits of code in Sonic Pi itself. So what this is doing, the synchronization command or the sync command, is it's using those different arguments that you've supplied as almost like a path, a way of finding where you are sending certain commands. So in this case, what you'll then notice is that I've got 3 different if statements. I've got an if statement on line 8 that says if val 0 is equivalent to start. And what this means is the 0th, because we're looking at an array, it's, remember, the first part of an array, the first bit of information in an array is known as the 0 index. So what we're asking there is Sonic Pi to look at the values that it's getting from val and then say, okay, well, what's the result of the first command that is being sent here? And if it's equal to start, then do this. If it's equal to loopy, then do underneath loopy. And if it's equal to pickup, then do underneath pickup. So each one of these values, start, loopy, and pickup, are the messages that I have programmed in Unity in the OSC communicator in order to send messages backwards and forwards between Unity and Sonic Pi. What will happen if you play your Unity project and try and move around is that you will see that Sonic Pi isn't doing anything. So I haven't played the Sonic Pi commands yet. That's just been sitting there. But you'll notice that even though you have Sonic Pi open, it doesn't automatically synchronize all of these commands up. The commands are being sent from Unity, and you can check that by using the OSC helper underneath the window menu, and you can see that there are messages being sent. The problem is that because I've not got Sonic Pi running, none of this is happening. If I go over onto Sonic Pi and hit run, you will notice that I start to get a thing playing because I've got this play 89 on line 4, so that's checking that it is actually working. But then you'll notice that if I jump back into Unity and hit play, what I can then do is see that there are commands being sent through from Unity that Sonic Pi is actually playing back. And then you can see that as I go around the environment, if I touch my object, the message is sent from Unity over to Sonic Pi via OSC, and that then plays. So in order for everything to work, just as an overview of the steps, what we're doing is we're downloading a Unity OSC framework or library. We're integrating that into a Unity project and setting up one important piece of information, which is what the commands will look like and how they will be sent. So what port, what IP address, so on and so forth. We then program in where we want our OSC commands to have an effect. And obviously that will vary depending on what you're trying to achieve, but basically that's what we're looking to do there. We then test that the OSC commands are being rendered properly by Unity by using the OSC helper that's part of the package that we downloaded. And then we go over into Sonic Pi, we set up what we want each command to do, and then we start both running. And what will then happen, assuming that everything is set up correctly, is that you will start to see communication between the two programs, and you will start to hear when, say for example, you interact with an object, Sonic Pi would play, and vice versa if you've got stuff going back the other way. So I hope that this is useful. I've left all of the samples that you can see on the video somewhere that you can download. Obviously that will be as part of this package. I'll have a little link for you to download stuff, and hopefully this gives you enough to work on to actually get your sounds up and running, where you can modify Sonic Pi as it's running from Unity. Hope this has been useful. Any questions, please let me know, and I will see you at the rehearsal on Tuesday evening, and hopefully we will start to see how everyone is doing and all the cool and awesome stuff that you've been working on. Thanks.